Hello, today's class is on diagram presentation of data. The purpose of classification and tabulation is to summarize and present the data in definite and systematic manner. However, these techniques of presentation of data do not help the common man to interpret the data in a meaningful forms as too many figures create confusion. Therefore, statistical results are presented through diagrams and graphs, which are important media for presenting the statistical data and highlighting their basic facts and relationships. While a graph is constructed on a graph paper, a diagram is usually constructed on a plain paper. A graph represents mathematical relationship between two variables, whereas a diagram does not represent such relationship. In the words of A.L. Bole, any list of figures become less comprehensible as its length increases. A series of 10 number can perhaps be easily grasped of 20 with an effort, whereas a painted list of figures for 100 successive years leaves hardly an impression on our mind. We cannot see the wood for trees. Properly constructed diagrams help the readers in understanding the data as they exhibit the statistical results in a clear and appealing way. Discuss significance of diagrams. Diagrams are widely used in business, economics, social studies, and other fields. They are extremely useful and occupy an important place in statistical methods for the following reasons. We'll discuss what are the reasons. Diagrams are attractive and convincing. Diagrams are visual form of presenting the data. They are impressive and eye-catching. Since they highlight the fact, they convey the message convincingly to those who are fed up with numerical data. Further, they attract the attention of the readers. Diagrams make the data simple and intelligible. Even lengthy and complicated figures can be presented through diagrams in a simple and intelligible form. Diagrams facilitate comparisons. With the help of diagrams, data relating to different time periods of different geographical regions can be compared easily and effectively. Diagrams have a memorizing effect. Unlike figures, diagrams act as effective aids of memory. They create an unforgettable image of the events in the minds of the readers. Diagrams save time and labor. To interpret and understand the present data presented in a diagram, we do not require much time and effort as in case of data presented in a tabular form. Diagrams are more informative. A diagram provides more information than a table. With the help of diagrams, we can easily understand the trends in the data. Though tables show the trends in data, they may not clearly reveal the information as in case of diagrams. However, diagrammatic presentation of data is not useful for in-depth analysis as they reveal only approximate values of the data. They convey limited meaning to the readers. Further, they are not convenient to present all the minute details of the data. It is difficult to construct diagrams, especially when large number of items are to be presented. General rules for constructing diagrams. What are the general rules? We will discuss now. Diagrams must portray the information in a simple, attractive, clear, and understandable manner. Hence, construction of diagrams require both talent and artistic qualities. The following general rules should be followed while constructing the diagrams. Okay, one is title. Every diagram must be given an appropriate title. Okay, as persons who requires name to recognize, title is most important in this case. The title should be clear, precise, and convey the central idea of the data. The title may be given either at the top or below the diagram. Proportion between width and height. A reasonable proportion between the width and height of a diagram should be maintained. If proper proportion between width and height is not maintained, the diagram should display the shabby picture, which would defeat the very purpose of visual presentation of data. Though there are no hard and fast rules regarding the proportion between width and length, a ratio of 1 short side to 1.414 long side is usually maintained. This proportion, known as root 2, was suggested by Mr. Lud in his book entitled Graphic Presentation. And the next one is scale. The scale should be incorporate all the necessary details of the data. As far as possible, scale should be in even numbers or in the multiples of 5 or 10. Example 5, 10, 15, 20, 25. Okay, or 10, 20, 30, 40, etc. And numbers such as 1, 3, 5, 7, 9 should be avoided as far as possible. The scale should clearly specify the size of the unit and what it represents. For example, rupees in lakhs, metric tons in millions, number of persons in thousands, etc. Footnote. Necessary footnotes should be given at the bottom of the diagram. This would help the reader in understanding the data without any ambiguity. Index. Every diagram should contain an index describing the symbol used, such as dotted line, colors, shades, etc. Simplicity. Diagrams should be simple and convey the message in clear and definite terms. However, simplicity should not be at the cost of objectivity. Neatness and cleanliness. Diagrams should be neat, clean, and impressive and attractive to capture the attention of the reader. For this purpose, different colors should be used. Okay. Next, types of diagrams. A large variety of diagrams are in use. However, a few we will discuss here, which are important and widely used diagrams. One dimensional diagram. Okay, two dimensional diagrams, three dimensional diagrams, pictograms, cartograms. We will first types of one dimensional diagrams, or we can say that types of bar diagrams. Okay, one dimensional diagrams are also called bar diagrams. They are commonly in use due to their simplicity. In this type of diagrams, data are shown with the help of thick lines or bars. In bar charts, height of the bars indicate the size of the item. Width of the bar is shown only to make the diagrams more impressive. Thus, width of the bars have no relation with measurement. The width of all the bars should be uniform. The gap between one bar and the other bar should be uniform throughout the diagrams. To present a large number of items, simple lines can also be drawn instead of bars. It is customary to write the representative figures on the top of each bar, which helps the researcher to know the precise value of each item and enables him to have a comparative picture of various items. Bar diagram can be drawn either vertically or horizontally. However, vertical bars are preferred as they give a better look and facilitate easy comparison of items of the data. We will discuss types of diagrams, simple bar diagrams. Among them, a few are discussed here. Among them, simple bar diagrams, subdivided bar diagrams, multiple bar diagrams, percentage bar diagrams, deviation bar diagrams. First, we will discuss simple bar diagrams. Okay, a simple bar diagrams are used to present the data relating to only one variable in this method. Each and every value of the variable is presented through a bar. The size of each item is identified with the height of the bars. If time series data are given, various values of the data must be shown in their chronological order. Okay. On the other hand, if the given data do not have any relation with time, values must be shown either in ascending order or in descending order. Once if you see, okay, if you look at PPT, you will see a diagram, okay, that is construction of a simple bar diagram using the data given. Years are given in 2007, 2008, 2009, 2010, 2011, 2012, 13 and 14. This data is pertaining to a time series in a chronological order, it is given. And year-wise sales in thousands of rupees also given. In the first year, that is in the 2007, 20, okay, 20,000 rupees of sales are there. 2008, 15,000 rupees. 2009, 30,000. 2010, 40,000. 2011, 70,000. 2012, 75,000. 2013, 90,000. And in the 2014, 100,000. That means 1 lakh rupees sales per there. Okay, this can be presented through a simple bar diagram. We can see and understand how it has been interpreted, diagrammatically represented this data in PPT. If you look, you can understand. Okay, next, subdivided bar diagram we will discuss. Subdivided bar diagrams are also called as component bar diagrams. According to this method, the bar is subdivided into various parts. While bar represent the whole data, its subdivisions represent different components of the data. To distinguish between various subdivisions of the bars, different color shades, crossing or dotted are used. Usually the largest component is shown at the base and the remaining components are shown in their order of magnitude. Generally, if we use chalk and pen or paper and pen, we use lines, shades or something else, but with the use of PPT, with the use of computer, we can make it colorful. Subdivided bar diagrams are useful to present both absolute and relative values of the data. However, it is more convenient to show a set of distribution ratios such as percentage distributions. Though the subdivided bar diagrams are useful visual aids, it is difficult to construct them, especially when the data are divided into large number of components. When you observe the PPT, you will come to know, okay, you will understand what is subdivided bar diagram. For example, here when you look at this, during 2001 to 2013-14, the number of students in a college are given. Okay, 2010-11 arts, okay, number of students in the arts is 100, commerce is 350, science is 300. In the year 2011-12, 200 arts students, 300 commerce students and 400 science students were there. In the 2012 and 13, art students were 250, commerce students were 300 and science students were 500. Okay, in the year 2013-14, the art students were 100, commerce students were 400, science students were 600. Okay, if you observe the total in the 2011, arts, commerce, science will be 750. In the 2011-12, it will be 900. In the 2012-13, it will be 1050. And in the year 2013-14, it was 1100. Okay, this given data can be presented through the subdivided bar diagram. If you look at the PPT, you will have the clear idea. Here 2010-11, we have taken 3 types of, and the blue color indicates what it indicates. Blue color indicates science, okay, and red color indicates commerce, whereas pink color indicates arts. Okay, number of students are taken on the y-axis and years are taken on the x-axis. The clear distinction between, okay, can be observed when we see, okay, when we look at the PPT, right? Next, multiple bar diagrams. Okay, multiple bar diagrams are constructed to present the data where comparison between 2 or more variables is needed. Construction of a multiple bar diagram resembles the simple bar diagram. The only difference between them is that the simple bar diagram is used to present the data of a single variable, whereas a multiple bar diagram is used to present the data of 2 or more variables. When we observe the example given in the PPT, okay, and construction of multiple bar diagram by using the, okay, data relating to the number of students in the university. Okay, Year wise he has given. In the year 2015 there are 1000 art students, 2500 commerce students and 4000 science students. In the year 2016 it was 2000 art students and commerce students, 2500 commerce students and 4500 science students. In the year 2017 2000 art students were there and commerce students were 4000, science students were 6000. If we present the same in multiple bar diagram, we will have the diagram in the when given in the PPT. How we have taken 0 to almost 6000, 7000 we have taken, 6000 we have reading. On y axis, that is number of students, and on x axis we have considered the years. 2015, 2016 and 2017, where blue color shows uh, science students. Is it right? Blue color shows blue color. How it is given? 4000. Science students. And red color shows commerce students, and pink color shows art students. It is very clearly visible the number of students who took admission in different courses in the different years given. Next, percentage bar diagrams. Percentage bar diagram. Under this method, the total length of bar is taken as 100. All the components of variable are converted into percentages and then are cumulated. These cumulative percentages are shown on a diagram dotted or crossings. Percentage bar diagrams are useful to present the relative changes in the data, but it is not easy to construct this diagram as it involves mathematical calculations. The elements of cost, sales and profit per unit of article X for the years 2015 and 16 are given here. If you observe the data, he has given in the problem that is given, material, wages, overheads are given for the year 2015 2016 in terms of rupees. When we add these total cost means the material cost, wages for employees and overheads. Total for 2015 will become 35 and 2016 it would be 50. Sales price is 40, profit will be 510. If you are selling with margin, total cost is 35 in the year 2015 and sales price is 40, you will get a margin profit of 5 rupees. Whereas 2016 the sales price is 60, whereas total cost is 50, hence you will get a profit of 10. If we represent this data in the form of a what we call it as a percentage bar diagram, we will have a diagram that was shown in the PPT. First we need to take the sale price per article X as 100 and express the other figures in percentages. The percentage obtained are given, that is 2015 material is 50%. Material is 50%, wages 25% and overheads 12.5%. Total is 87.5. Sale price 100. Profit will become 12.5. Whereas in 2016 the material is 41.7% and wages were 25%. Overheads were 16.7%. The total will become 83.4%. Sale price will be, if we assume it as 100, the remaining will be the profit, that is 16.6%. This can be represented through a diagram that was in the PPT given, that is percentage bar diagram. We have taken years on y axis and cost, sales, price, profit in rupees on the x axis. And that can be easily understood with the looking at the diagram. Next, deviation bar diagrams. Deviation bar diagrams are used to represent the net deviation in the different values of the data, such as net profit, net loss, net exports or imports, that is balance of trade. While positive values are shown above the base, negative values are shown below the base. Okay, we will take one example. Okay, present data by taking sales proceeds and cost. Okay, difference between sales proceeds and cost of firm A. He has given years 2012 to 16, sales proceeds and total cost. In the year 2012, we have sales proceeds 50, total cost 40. 2013 100, 50, 2014 200, 180, 2015 500, 450, 2016 775. Okay, now with the help of this data, we can construct a deviation bar diagram. Okay, in order to construct a deviation bar diagram, okay, we need to consider the data. The above, as we have said, profit loss in rupees. Okay, profit loss in rupees. Based on the profit and loss only, sales minus total cost is equal to, we will get profit. If sale price is higher than the total cost, certainly we will get profit. If sale price is less than the total cost, then certainly we will get losses. Here only one item found, that is in the year 2016 minus 25, that is loss is given. Hence it is a deviation bar diagram. All the 3 years, all the 4 years, for all the 4 years it is positive, whereas in the 5th year, that is in 2016, a negative bar diagram. Okay, deviated bar diagram we have. Okay, a bar we will get, right? The difference between sales proceeds and costs will be understood with the aid of this diagram. Okay, in the 4 years, consecutive years, we got profits, whereas in the last, that is 2016, we could make losses. Next, broken bar diagrams. Broken bar diagram, sometimes there may be wide variations in the given value, as some of the values may be very small and others may be very large. In such cases, to adjust the space and show all the components in an intelligible manner, the largest bar is broken. Okay, with the following data, we will represent the same. Here the colleges were given, 4 colleges we have considered, M, N, O and P. We took the names as M and O, P. Number of students in BBA class. Okay, if you consider number of students in a BBA class, that is 50, 100, 325. Okay, solution, the number of students, when we consider the solution, the number of students of college O is maximum 12 times that of college B. Okay, in order to gain space, we have broken the bar for college O, otherwise the length of this bar would have been 12 times that of the bar of the college B, and the diagram would have occupied a lot of space and given an ugly look. When you observe this, number of students were taken on the college wise, and the colleges are taken on x axis and the strength will be taken on the y axis. You will observe that bars, okay, different. Next, two-dimensional diagrams. Two-dimensional bar diagrams are also called as surface diagrams or area diagrams. While constructing them, both width and height of the diagram are to be taken into account. Thus, following are some of the important types of two-dimensional bar diagrams. Okay, one is rectangles. Okay, rectangular diagrams are used to represent 2 or more sets of data. The area under a rectangle is equal to the product of its height and width. While drawing a rectangle, the original value of the data can be used. Alternatively, the percentage value of various components can be used to construct a rectangular diagram. The latter method is particularly useful to compare two or more sets of data. However, it is very difficult to interpret a rectangular diagram as it involves the problem of judging the area. These diagrams are not useful to present the data, especially when the values of the data have a wide range of fluctuations. Well, we will consider one example for the sake. Rectangular diagram. Prices of items are given. Price per unit of commodity of X and Y. There are two commodities are given, X and Y. The price of the unit of commodity of X is 20, Y is 25. Quantity sold 50, 60. Cost of raw material 500, 540 respectively. Other costs 250, 300. Profit 250 and 660 respectively. Now with the use of this we can draw a rectangular diagram. Okay. In order to draw the rectangular diagram, commodity X, okay, 50 units and commodity Y 60 units we will consider. Cost of raw material, okay, 500. Per unit it will be 10 rupees. Okay, we are considering X units as 50, hence 500 by 50. Okay, we will get 10. Other costs 250, 250 by 50, 5. 250 profit 250 by 50 units. The other cost per unit will be 500. Commodity Y 60 units we have. Total amount of cost of raw materials is 540. If we divide the same with the number of units, we will get the per unit. Okay, price of per unit. 540 by 60 we will get 9. 300 by 60 we will get 5. 660 by 60 we will get 11. That is per unit of commodity Y. Okay, price of per unit commodity of Y. If we draw the same, if we take 0 to 30 on Y axis, that is cost profits per unit in rupees, okay, and 50 units 60 units on X, 50 units of X and 60 units of Y on X axis. Okay, we will get a rectangular bar diagram. They are like multiple bar diagrams only. We will get that. The costs and profits per unit of commodity X and Y, that will show. Okay, for example, here cost of raw materials will be in the pink, and other costs are taken in the red zone, and whereas profits are given in the form of blue color. Okay. Next, two-dimensional diagrams. We have squares. Another type is squares. Uh, Square diagrams are used to present the data, especially when the value of items have a wide range of variation. While constructing a rectangular diagram, width and height of the diagram are maintained in proportion to the given values. This rule often results in an ugly shape of the diagram. To overcome this difficulty, square diagrams are preferred to rectangular diagrams. While constructing a square, the square root of the value of items are computed and presented in a suitable scale. Here, we will consider one problem that is formed by a square diagram. Years is given 2002, 2003, 2004, and whereas sales are given in rupees, that is for 2002 it was 1600, for 2003 it was 2500, whereas in 2004 10,000. Okay, for the sake of convenience, if we consider the solution, since there is a very big gap between the first year sales and third year sales, a square diagram may be quite suitable here. The side of the square diagram, square will be determined by the square root of the value to be represented, and the size of the side of various squares shall be proportional to the square roots of the various quantities to be presented. Okay, here years are 2002, 3, 3, sales 1600, 2500, 10,000. Square root will become 40, 50, 100. Okay, if we take the square root of sales, we will get 40, 50, 100 respectively. Side of the square in inches will be 0 for there are four sides for a square. We have taken 40, 10 each, then 0 0.4, 0 0.5, 1.0 will be the sides of the squares in inches. Then with the aid of these figures we will draw. Okay, each figure of the square root has been divided by 100. At the side of the square octane we will have, when you see at the when you look at the PPT you will understand the dimensions. Okay, next circle or pie diagrams. Circle or pie diagrams. Okay, these diagrams are used to present both the total and the component parts or sectors of the data. The area of a circle is proportional to the square of its radius. Separate circles are drawn by taking the square roots of various figures. The area of each circle depicts the magnitude of different items that are presented. Usually, a pie chart is constructed to present the various components of the data. Construction of a pie chart requires the following steps. One is, take the total value of the item as equal to 360 degrees. Convert all the components of the data into degrees. Draw a circle. The size of the radius of circle cannot be determined on the basis of the space available and other rules of diagrammatic presentation. Measure the points on the circle representing the size of each sector with the help of uh, protractor. The value of various components of data are shown in a pie chart in order of their magnitude. The large value is shown first at the top and the other in sequence in a clockwise pattern. When more than one set of items which contain various components are to be represented, separate circles are drawn for each of such item and their components are depicted in the circles. Thus we obtain as many number of pie charts as number of items. Though pie diagrams are useful devices for presenting the data in an impressive manner, they are less effective when compared to bar diagrams. Accurate reading and interpretation are not possible, especially when the variables are divided into large number of components. They are also not effective when the difference among various components is negligible. Okay, here we will consider uh, help circles. He has given years 1984, 85 and 86. Okay, sorry, he has given years for 2002, 2003, 2004. Okay, whereas sales were in the 2003, that is 1600, 2002 1600, 2003 is 2500, and in the year 2004 it was 10,000. Okay, 10,000. The side of square has been obtained. The sorry, sales of firm during 2002 to 2004, as the size of the circle increases with the volume of the sales, right? The proportionate increase will be, we will observe it. If you take uh, circle, diameter of circle for 0.23, if we take it as first, second one will be 0.28 and 0.56 will be the bigger one, that is I mean 2004. Okay, next we have another pie circles of cycles. We have pie chart. We will discuss one pie chart here. uh, Here we have one pie diagram showing monthly expenditure of family X. Okay, the items are given. Items of expenditure food on food, clothing, rent, recreation, miscellaneous were given, and family X. Okay, having they'll spend 45 rupees on food, 20 on cloth. 45 means 45,000, not 4,500. You may say that given in hundreds, 4,500 for food. uh, okay, 2,000 will be for clothing, 22,000 will be on rent, and 1,000 on recreation, and 5,000 on miscellaneous. Okay, if you 500 on miscellaneous, then you will, with the help of, you can draw first items of expenditure. We should express them in terms of rupees and degree. If total amount, total will be the 100 rupees. Okay, total, so that means 10,000 rupees they are spending. For 4,500, how much it is? The 4,500 by 100, okay, is into 360 is equal to 162. Whereas 2,000 by 100 into 360 is equal to 7,072. And in the same manner, if we divide, you will get for rent 72 and recreation 36. This total will be equal to 360 degrees. If we divide the same, if we apply the pie chart formula, if we draw the based on the 360 degrees taking a protractor, we'll see a pie diagram that was shown in the PPT. Right, next, three-dimensional diagrams. Here I am considering one cube, and another is rectangular cube, that is prism. Okay, and the side of the cube is obtained by dividing the cube root by 20. We have an example in this. Okay, I will tell you. The number of students in University K for 2 consecutive years are given. In the 2011-12 there are 1600 students, and 2012-13 2500 students. First we will number of students considering cube root we need to do. Cube root of number of students is 11.69, 2500 is 13.57. Side of the cube is 0.58, 0.69. Okay, based on this, these cube root of for the given year, that is for 2011 and 12 will be anti-logarithm of 1 by 3 log 1600, that is anti-logarithm of 3.2041 by 3, anti-log of 1.068, that will become 11.69. If we use the 11.69, by using the 11.69 one side of the cube, we will draw first one. And if cube root for the year 2012 and 13 is anti-log 1 by 3 log 2500. Antilog of 3.3979 by 3 is equal to antilog of 1 is 1.1326. That will be 13.57. 13.57 will be the rectangular bar, okay, side of the rectangle. Hence, with the aid of three-dimensional diagrams also we can present the data. Construction of three-dimensional diagrams involves complicated mathematical calculations. It is not only hard to construct but also difficult to read and interpret. In view of these practical difficulties, three-dimensional diagrams are not recommended for statistical presentation. Okay. Next, we have pictograms. Okay, pictograms attract the attention of the readers quickly, as they really depict the kind of data and that is presented. According to this method, data is represented with the help of carefully selected pictorial symbol. Pictograms are highly useful statistical devices of presenting the data, especially to a layman. The pictorial symbol selected should be self-explanatory. For example, if we wish to represent the data relating to telephones, the symbol should clearly indicate a telephone. As far as possible, symbols should be clear, concise, interesting. Changes in numbers should be shown by more or fewer symbols, but not by larger or smaller ones. Pictograms are used to attract the attention of masses in the public places like exhibitions, trade fairs, etc., as they create an image which cannot be forgotten easily. However, it is not easy to construct a pictogram as it requires an artistic talent. Further, it is not possible to show all the minute details of data in pictograms. Here we will consider an example. Here are given production of cars. 2012, 3000 cars are given. I am only representing 3 in thousands. There are in the PPT, we have a pictogram for indicate the production of cars. In the 2013 there are 4,000 cars production. 2014 it is 6,000. Whereas in 2015 8,000 cars are produced. Whereas in 2016 12,000 cars were produced. With the aid of pictograms we can present the data. And cartoonograms. Okay, cartograms, or we can say that mapographs, are used to present the data on geographical basis. Which geographical unit is clearly shown on the map and their respective values are identified with different colors, points, dots, or crosses. Like pictograms, cartograms are also extremely useful visual aids of presenting the statistical data to a layman. If you consider the rainfall, will forecast, weather forecast in the form of cartograms, or we can say mapographs. Okay, and okay, lastly, choice of suitable diagram. Okay, the selection of a suitable diagram depends upon the nature of data and also the type of people to whom the message is to be conveyed. If the message is to reach the illiterate people, it is better to use pictograms or cartograms. A pie chart is useful when a large number of components is to be presented. Cubes are preferred where the difference between the smallest and the largest value to be presented in a significantly large. However, bar diagrams are widely in practice as they are easy to construct and simple to interpret. The selection of suitable bar diagram depends upon a few considerations. One is simple bar diagram should be used to present the magnitude of the values. Subdivided bar diagram should be used to present the relative changes and relative importance of various components of the data. Percentage bar diagram should be used to present the relative changes and relative importance of various components of the data. Multiple bar diagrams should be used to represent the two or more set of data. Okay, with this we have finished this topic. Thank you.